Hey guys, so and for basic differentiation rules, I told you guys towards the end of the video that I would show you a proof of why the derivative of sine is cosine and the derivative of cosine is the negative sine. So let me go ahead and just begin by titling this video. So this derivative of sine is cosine. Okay, so let me go ahead and show you by taking the limit definition of the derivative for the sine. So remember that the limit definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So let me go ahead and apply that for the sine function. So the limit as h approaches 0 of sine x plus h minus sine x all over h. There's a rule in trigonometry that you guys have learned. It's a property. It's called the sum angle property for trig. So sine of a plus b is the same thing as the sine of a cosine b plus the sine of b cosine a. That's a rule, and that's a property. It's always true. Anytime you take the sine of two angles being summed, you can rewrite that sine a plus b as the sine of a cosine b plus the sine b cosine a. Okay, so let me go ahead and apply this. This is my a, this is my b. So it's going to be the sine, well, the limit as h approaches 0, sine x cosine h plus sine h cosine x minus sine x all over h. Okay, so now here's what I want to do. I have this weird trig stuff in my numerator, but there's really nothing I can do much except for just factoring out the sine x. So before I factor out, let me go ahead and group these highlighted parts together. So let me actually rewrite this as the limit as h approaches 0, sine x cosine h minus sine x plus sine h cosine x all over h. All I did was move this negative sine x in between the cosine h and the sine h. So now that I can factor these sine x's out, I'm going to go ahead and factor these guys out. It's going to be the limit as h approaches 0 of the sine x factored out becomes cosine h minus 1 all over h, and then this becomes plus sine of h cosine x over h. So what I did, I split up the fraction. Okay, I split up the fraction. I made this one fraction. I made this one fraction, and I went ahead and already factored out the sine to the outside. Okay, well, let's go ahead and take a look at this part right here. This highlighted part right here. That looks very familiar. That looks a lot like your one of your definitions of the limits that you guys have seen from your trig, the trig definition limits. So let me go ahead and rewrite that so that it becomes more familiar. So it's going to be sine x. I'm going to factor out a negative so that when I factor out a negative over here, I get 1 minus the cosine h all over h plus, and do you see this cosine x? I'm going to move it to the front, and I'm going to leave it as sine h over h. And now I'm taking the limit as h approaches 0 of everything. Well, this highlighted part here is a limit rule. This other highlighted part here is another limit rule, and we know these rules. We know that the limit as h approaches 0 of sine x over x is 1, And we know that the limit as x approaches 0 of 1 minus cosine x over x is 0. But this time we have h. Well, it doesn't matter because notice that we're taking the limit as h approaches 0. Here I have an h, here I have an h, h and h. All this becomes 0. All this becomes 1. So my derivative, all this goes away because it's 0 times anything. 1 times cosine just is cosine x. And that is my derivative of the sine. Let me go ahead and show you the other one. So if I have f of x is equal to cosine x, I want to go ahead and show that the derivative of cosine x is a negative sine x. Same thing. I'm going to use my derivative rule, my definition. It's going to be cosine x plus h minus cosine all over h. Now, similarly with the sine one, there is a rule for this. Anytime you have a cosine a plus b, that is the same as the cosine a cosine b plus the sine a sine b. So rewriting this becomes cosine x cosine h. Oh, I messed up. I'm sorry. When it's plus, it's minus. The cosine has alternating signs, so it's just going to be a minus here. So it's going to be minus sine x sine h minus cosine x all over h, and the limit as h approaches 0. Okay, so very similar. I'm going to go ahead and factor out a common factor. The only common factor that I have is the cosine x and the cosine x. So let me go ahead and rewrite that. Let me rearrange the order of these terms so that we can see it very clearly what's going on. So it's going to be the limit as h approaches 0 of cosine x cosine h minus cosine x minus sine x sine h all over h. Factoring the cosine, I get cosine h minus 1 all over h minus sine x times sine h over h. Okay, I did the same thing like in the previous problem. I split up the h's. I could even split up that part there. Well, what is the limit of cosine h minus 1? Well, we found that to be 0. What's the limit of sine h over h as h approaches 0? That's 1. So cosine times 0, all this is 0. Negative 1 times sine is just negative sine. So my derivative of sine x is cosine x, and my last derivative is cosine. The derivative of cosine is a negative sine x.